All right, happy Monday. Moving into a new unit. Our unit is now expressions and equations. We spent a lot of time in expressions and equations. Majority of quarter two, and going into January. So that's kind of what we were tackling then. Our task for today is to add and subtract linear expressions with rational coefficients. So again, vocabulary plays an important part here. Coefficient is just a fancy term for the number in front of a variable. That's the coefficient. So 4 is a coefficient, 2 is a coefficient, negative 15 is a coefficient, 2/3 is our coefficient, 4/3, 5 technically, 2, and 1/3. Those are all coefficients, the number that precedes or goes in front of a variable. So we're going to practice adding and subtracting expressions with rational coefficients. Now, right off the bat with our first example, you'll see that we have both subtraction signs and negative signs. That can get a little bit tricky just because, one, they look the same, and two, we're thinking, okay, if I have a negative, how do I take away negatives? Sometimes that can get a little tricky. So hopefully you remember our rule that subtracting is the same as adding the opposite. And last week we practiced rewriting expressions. Instead of subtracting, we rewrote them as adding the opposite. So that's what I would start with doing for these examples when we have lots of negative numbers. So I would rewrite this as negative 4p plus, so adding the opposite of 2r would be negative 2r. And then minus 15p, again, I'm going to change that to adding the opposite of 15p would be negative 15p. So I can clearly see, okay, I have a negative 2r and I have negative 15p. The nice thing about this also is that if I am adding, hopefully you're thinking about those properties that we talked about last week, that now, because I'm adding, I can move the order any way I want to. And so in this case, I think it makes the most sense to move this negative 4p pens are waking up. This negative 4p next to the negative 15p. And the reason for that being is that they are like terms. Like terms mean that I can combine these because they have the same variable. We can't forget about this plus a negative 2r though. So now I'm ready to combine or add. So negative 4p plus negative 15p, well, these are two negatives, so according to my rule, if they have the same sign, I add them and I use the same sign. So 4 plus 15 is 19. So that would be 19p, but it would be a negative 19p plus negative 2r. Now I can't combine this negative 2r with negative 19p because they have different variables. I can only combine these two because they are like terms. These two are not like terms. So actually my most simplified version of this expression is negative 19p plus negative 2r. Now again, because subtracting is the same as adding the opposite, I could also write this as negative 19p minus 2r. These are equivalent. Okay, so these would be my answers. Either one of these will work. They are the same. Okay, now that would seem pretty simple. When we move on to rational coefficients, that means we're looking at coefficients with decimals or fractions, our favorite. So before I get started here, I'm going to take a look at what my like terms are. So here I have 2/3 p. I have 4/3 p. 5, I can't combine with these two because there is no p variable here. So these two are like terms, 2r, nope, not a like term. This 1/3 p is a like term. So I have 3 like terms that I combine. These two can't combine. Again, though, I want to start by rewriting this expression to add the opposite because we've learned that that's equivalent. So I'm going to rewrite this as 2/3 p plus 4/3 p plus 5 plus 2r plus, adding the opposite of 1/3 p is negative 1/3 p. Okay, and so now I'm ready to combine these like terms. Now I'm lucky here that these fractions all have the same denominator. So can I just add them all together? Yes, I can, because they have the same denominator. Now let's say we had different denominators here. We have to find a common denominator. So that means finding common multiples. What number do each of those go into? So that's kind of a review from 4th, 5th grade. But for these purposes, we're going to keep moving through. So I'm going to combine 2/3 p plus 4/3 p. 2/3 plus 4/3 would be 6/3. And then adding, let's actually do that part first, 6/3 p plus a negative 1/3 p. And then don't forget about the 5 and the 2r, plus 5 plus 2r. So when I combine 6/3 plus negative 1/3, remember if we have different signs, we actually subtract them and we use the sign of the bigger number. So 6/3 minus 1/3 would be 5/3. And the bigger number is a positive, so I'm going to keep 5/3 as a positive, 5/3 p plus, can't forget about those two, 5 plus 2r. Now, can I simplify this at all? Well, here we have 2r. Do I have any other r's? No. Here I have a 5. These two have variables that come with. So this is actually as simple as it gets. Now, if I want, I can simplify this improper fraction. 5/3 can be turned back into a mixed number if we divide. So 5 divided by 3, 3 goes into 5 one time. You guys know the drill. This could also be written as 1 2/3 p plus 5 plus 2r. So both of these could end up being our answer. Okay, so remember to combine like terms. Don't be afraid of the fractions or the decimals, and good luck.